It'll be kind of like your exponent rules. It's just going to make things easier. You don't have to prove them all the time.
He told me to remind you to.
I'm recording it right now.
I just
Yeah.
wanted to make sure, like, I delivered the
Yep.
message.
Perfect. It's recording right now. Thank you. So it's like the quick rule. So you don't have to prove it every time. We're going to go through and prove each one, but you're never ever going to have to do that. You're just going to have to remember the rules. So the process of finding the derivative is called differentiation. So just so you, like, the derivative is the actual expression, like that we talked about yesterday, that f prime one, the derivative is the actual expression. The act of finding it is called differentiation. So the point of these is just to kind of make it go faster, and they're like mathematical known truths. You don't have to like prove them every time. Okay, so where f of x is equal to k, where k is a real number. So that would like being saying f of x equals 3, right? So just a real number could be 3.5, could be 3.2, could be, you know, negative 1 million. But so what would an f of x equals a constant look like? What kind of graph would that look like?
There's going to be a flat, right?
Is it going to be horizontal? Yeah. So if we graphed y equals 3, we're going to have that. Miss Steve, I love it. Miss Steve's getting a shout out.
She yelled at me till like my ears bled.
I wonder
y
why.
equals 3, that is a horizontal line. That is a vertical line.
And so what have you, but you know what? It's stuck in your head. So here's how we prove it. So again, I'm putting that slope formula in. So that's going to be f of x plus h minus f of x all over h. So, okay. So now that we have that pretty picture, I'm going to ask you a question. Let's say we're going to use 3. That would make the most sense, right? What's my x value? If x is 1, what's y? 3. And if x is 2, what's y? And if it's 3, it's 3. So it doesn't matter what the x value is. What do we know about the y values?
Must be 3.
They're always going to be that constant number. In this case, we were talking about 3. So really, it doesn't matter how far you are away from that x value. It's a constant value. So my y is going to be whatever that constant value is. Oops, sorry, you can't see that. So if we did direct substitution here, we're going to get an indeterminate number, right? Everybody would agree with me, it'd be 0 over 0. So then we'd have to approach left-hand, right-hand side. So we would have to look at the limit as h approaches 0 from the left-hand side. That'd be 0 over h. And the limit as h approaches 0 from the right-hand side. So I wrote those out, but I didn't really need to. If h is coming from the left-hand side, it's going to be like a negative 0.001, right? It's going to be a really small negative number. So if I take 0 and divide it by a really small negative number, what am I going to get? 0. If I come from the right-hand side, so it's going to be 0.0001. So I'm taking 0 and I'm dividing it by a really, really small positive number. Also 0. So where is this approaching? 0. So we know that the limit of a constant function, so we know that the limit as h approaches 0, I guess it would be 0 over h is going to approach 0. And the only way I would know that is doing the left-hand side, right-hand side. Because if I do direct substitution in here, I'll get an indeterminate. So as soon as you get an indeterminate or an undefined, you got to do more math, right? So we did some ish math here for these ones to figure out where we're going to. So what you need to know is the derivative of a constant. So we know f prime of x, where f of x is equal to k, we know that that's going to be 0. So if my function is equal to a constant, the derivative will have a value of 0. And again, we're going to use these as we solve for more derivatives. So if you're starting out with y equals 3, you know the derivative of that is just 0. You don't have to do any math. You don't have to prove it to me. This is just the formal proof that it actually works. You can just put in 0. Okay, so
The graph is a straight line, like the slope is always 0.
is always 0 too. Yep, that's a great way to discuss it too, right? We know that the slope of this line is 0. Okay, power rule for derivatives. All right, so with the power rule, so if I have a function, let's say x squared, what happens is that the original exponent gets pulled out in front, and then you reduce the exponent by 1. So that's what they're telling us. They're telling us that the derivative, the f prime, would be 2x to the exponent 1. So that 2 ends up getting pulled out front, and then you subtract 1 from the exponent. All right, so we're gonna do the verifying of the rule. Okay, so we have, and you can write it like this too. You might see it like this in some places, and that's okay. That would be f of x plus h minus f of x all over h. So all we're saying is that the derivative is equal to the limit of the slope where h is approaching 0. All right, so what do we know? We know that we've done this one before. I feel like we did this one yesterday. So we know that we're going to replace this and we'll use the x squared function because I think that would be, if we actually use a function, it would be helpful. This is why we're going to verify it. The other one was a proof. This one's a verify because I'm using an actual function to verify this one. So we're going to put the x plus h in where we see the variable in that one. So this is going to be x plus h squared, and I've left us no room. Tried to cram it all in here. So this is going to be x squared plus, I'm just going to combine terms because I know what they will be. We did this one the other day. I feel like we've done this one the other day. And then we're going to divide that h, or common factor that h out and divide it out. So this would be limit. Oh, there's double i's in my word limit. That's not good. Can't even spell limit today. H as h approaches 0. So we're going to have h 2x plus h. So we know that if we do direct substitution in here, we're going to have 2x plus 0
Miss Scallion?
Yep.
Isn't it 2xh plus h squared? Oh, then you, okay.
I common factored out that h,
Yeah, okay.
right? Just so I could cancel it out really quickly. So we verified that it works, and you can do this every time. Like if the quick rules aren't coming to you, you can definitely do it the long way, but once you get the hang of this, this goes way faster. Like if the exponent is 3, you pull the 3 out to a coefficient, and then your exponent gets reduced by 1. Pretty straightforward. Okay, are we good with that? I'm flipping the page.
Today's lesson is one of the best lessons.
Best lesson, because it's nice. We're going to do it quickly. Okay, it's an important pattern. 2 important patterns. Exponent of the derivative is 1 less than the original function, and the coefficient of the derivative is the exponent of the original function. So using that rule we just had, what would be the derivative of this one? What would be the derivative? What happens to that 4? The exponent gets pulled out front to become a coefficient. We keep the x, and then what happens to our exponent?
3?
It reduces by 1, so it's going to be an exponent of 3. So you just found the derivative without doing any of that big ugly stuff. Okay. So notice I use f of prime here because this was f of x. If this one's given to me as y, what am I going to use? Y prime. Yep. We don't want to introduce f of x because it wasn't in the original equation. So y prime is equal to what happens to the exponent? Gets pulled out front. So now it's a coefficient. We keep the x, and then we're taking, and I'm going to actually do the math here, minus 1. And we know that we need common denominators. So we would have 1/3 x to the exponent 1/3 minus 3 over 3.
Minus 2/3?
So we would have y prime equals 1/3 x to the exponent negative 2/3. Now, that's a whole lot of mess if we were to need it as a positive exponent or put it as roots, but we in calculus are very comfortable leaving it here. What does the negative tell me I have to do?
Gotta
Reciprocate that base. And this exponent is only applied to the x, so this would be 1 over x, right? What does the 3 tell me to do? Cube root it, and the square tells me to square it. So that'd be really ugly if we put it there. We're okay with leaving it like this. And the reason why we're going to leave it like this is because we're going to do these derivatives again for second and third level. And once you start putting root signs and fractions, it gets really ugly. You guys are going to find in calc, we don't do a lot of simplifying. We leave it like this and we walk away. Like, we don't get caught up in making it look pretty like we did in grade 12. Okay. Now this one, now just saying that, now it's a big fat lie. I've just told a big fat lie. The reason why this one is a little bit difficult, I'm not going to do the prime function first. I'm going to rewrite this with it out being a fraction. Can you do that? What would it be?
X raised to power negative 4.
Right. So if we do this, all of a sudden, because these two things are equivalent, the 1 over x to the exponent 4 is the exact same thing. So the function is the original, there's no prime on that. I just rewrote it a different way. Now it's so much easier to do my derivative.
Now this dot is equals to negative 4 times x to the power negative 5, right?
Yeah, good catch on the negative 5. How many people would have went 3? I probably would have been that person. I would have put negative 3 because that 1 less than 3 or 1 less than 4 is 3, but we're going in the negative direction, so it has to be a 5. So another tricky one here. There's no exponent shown, but we can totally write it as an exponent.
X equals to 1/2, I mean, x to the power 1/2.
Right. And so once we have it just as a single power, then we can apply that power law, and it's so much simpler to do the derivative rules. So again, it's my original function. These two things are equivalent. I haven't changed the value of them. Now I'm going to do my derivative. I didn't show any math there, but I figure we're okay with that. 1/2 minus 1 leaves me with a negative 1/2. Okay, easy peasy. So that's kind of like how we're going to use the rule, and then there's just like a couple of tricks that you probably want to leave it as a single exponent. Okay, derivative of a constant times a function. So number, actual function, so like for x cubed, the exponent only applies to the variable, it doesn't apply to the 4. So all this is saying is you're going to find the derivative of this, and you're going to multiply it by 4. That's it. So if we were to do the quick rules, what would that be? Okay, so if we do g prime of x, so we know that g of x is just the variable thing, So if we do g prime of that, that's going to be 3x squared. And then to find the whole function, to find f prime, that would be 4 times 3x squared, which would be 12x squared. Right? So if I do the quick rules, that's how fast I can do it. Now we're going to do it the long way.
You don't have to do it the long way.
We're going to do it once, and then you never have to do it the long way again. But it's good that you practice the definition of the derivative, because I am going to ask you to show that to me on the quiz. So, how am I going to start this?
You stuff it in a limit.
I definitely stuff it in a limit. So we're going to say the derivative of x, because we're doing an f of x function here, and the g of x is just a part of it. The g of x is just a part of it. So the derivative is the limit as h approaches 0, and then we're just doing the slope formula. So f x plus h minus f of x over h. That is, I'm just going to take my handy dandy highlighter. Oops. That's that definition of the derivative there. So I will ask you to do that on your quiz and your test for the L, or for the D2 outcome. Knowing how to do this is that D2 outcome. So you can't use your basic rules until D3 or after. Okay, let's fill in some stuff. So the first one, I go back to this formula, and it's going to be 4 times x plus h cubed minus 4x cubed all over h. Now, how much do you guys trust my math? Hopefully. Not at all? Okay. That's fair. We've been together long enough that you can say those things to me. Okay, I'm just going to pull this off to the side. So I have x plus h times x plus h times x plus h times 4. So I'm going to do these two things first. Oops, forgot my 2. Because we've done this one already, right? We've done this one a million times. So now what I'm gonna do is I'm gonna multiply these two together. So I leave my constant till the end. I don't know, it makes my brain happy. So I'm gonna leapfrog backwards. So I'm gonna have x cubed, and then I'm gonna have plus 2x squared h, and then plus h squared x. And now I'm gonna do my h's. So I'm gonna have plus hx squared, and then I'm gonna have plus 2x squared h, my pen's running out, and then I'm gonna have plus h cubed. And I gotta times that all by 4, but I'm gonna combine any like terms I see here. So I have 4x cubed, so this one and this one go together. And then this one and this one go together. Oh my goodness, now I gotta do 4 in there. Okay. So I'm gonna hop back to my page for a second. So I'm just gonna be copying.
Nicholas Hampton, please report to the office immediately. Nicholas Hampton, thank you.
Yeah.
Oh my goodness. So you see why the derivative rules are kind of handy. So we don't have to do this excessive amount of multiplying. And the multiplying isn't hard, it's just, it's lengthy. It's lengthy, and there's definitely things that I could do wrong for sure. So I'm gonna skip a step. I'm gonna look at these ones. Guess what I'm gonna do? I'm gonna common factor out an h. So I'm gonna have an h, and I'm gonna be left with 12x squared plus 12xh plus 4h squared. Oops. All over h. So those h's are going to cancel each other out. And now, so we are left with 12x squared plus 12xh plus 4h squared. I don't know why my bracket's so big. I don't have a denominator anymore. If I do direct substitution into here for h's, this one's going to go away, and this one's going to go away.
12x squared.
Which was an awful lot of work, and we got the exact same answer using the quick rules. You just got to remember them. And all of these basic ones, I believe, are on your formula sheet. Like all of these are listed on there. Okay, so I want you guys to differentiate.
Wait, but Miss Gallia.
Okay, yep.
When you have like in our slope formula like fx plus h minus f of x, so how do you know like what to put in the x plus h?
Because I go back to this formula,
Okay.
because this was the one we were using.
Yeah.
So the x plus h, I replaced the variable in the original formula with x plus h. So I did that right there. Because the formula is 4x cubed, so I replaced the x with x plus h in the formula.
Oh.
And that's why I had to do the big expansion on it.
Okay.
Okay, so at the bottom of the page, I'd like you guys to go ahead and try to differentiate using the quick rules. Please don't, well, I mean, you can do the long ones if you really want to.
Miss Gallia, can photo like I'm just going to check my answers.
Mm-hmm. Photomath will do it, but it won't show you the steps.
Yeah, I don't need this step.
You don't need, I love it, you don't need the steps.
No, I just want to make sure that.
Because you got to pay for those.
Some of them showing basic steps.
True, yeah.
It was only like $10.
$10 a month, easy peasy.
I got my dad's credit card.
Nice. Can I borrow your dad's credit card?
Yeah, I'm not gonna work it.
What? So did everybody use y prime? So I might, so I'm going to leave the -2 there, and then I'm just going to differentiate that. I'm just going to differentiate that. So the -3 comes out front, and the exponent is reduced by 1, so that's going to be to the -4. So that -2 stays put, and then I differentiate just the variable.
Do we need to show it in 2 steps?
No, you do not. Nope, you can do it all at once, that's fine. I like to just show like the process in which I'm doing it, just so that when we look back or, you know, Snee's watching this video, we've got all the pieces to it. Sometimes I find when I skip stuff, it confuses. It's more hurtful than it is helpful. And I would definitely make mistakes.
I was watching the first lesson yesterday with my grandmother.
Your first lesson with the grandmother, with your
No,
grandmother?
Yeah.
Yeah.
Yeah, like, thank you for making the videos, it really helps.
Yeah, did grandmother learn it?
She was like really, really confused. Oh,
What do you call your grandmother?
no, I didn't even bother. She
What
told-
do you call her? Like, I called my grandmother Siti. Some people call her grandmother's granny. Like, what's
City, like, what?
Siti's Lebanese?
Oh, is she Lebanese?
Yeah, my mom is. Yeah.
Hey, really?
Yeah.
Wow.
So what do you call your grandmother?
That's fine.
Nanu?
It's
Okay.
like nani is for like mothers, like it's from mothers.
Okay, so the
Mother.
maternal grandmother, yeah.
And for fathers, mother we say dadi.
Okay. So is it more T's, like than D's, like?
Like for the father it's
Mhm.
dadi, D-A-D-I.
Okay,
And
okay.
for mothers it's nani, N-A-N-I.
Oh, okay. All right.
And if it's grandfather it becomes nana, N-A-N-A.
Okay.
And for like dadi it becomes dada.
Okay.
D-A-D-A.
Very cool. What do you call your grandparents?
There's Mayor, Prepare, Grandma, Grandpa, and Nanny and Opa.
Nice.
My grandpa was born, Opa was born in Holland.
Okay, nice. See, we all have something. Okay, so this is the add and difference. There's really nothing crazy about it. You're just deriving both functions and then adding them together, or deriving both functions and subtracting them. Like, it's pretty straightforward. So if I were to do this one, I got to find the derivative of this. This would be the derivative of f of x. And then this one would be considered g of x. So essentially, you're treating them like they're two separate equations, and then you're doing the derivatives of them. And I'm always going to show my 2 steps, just because it helps my brain. It doesn't take me extra long to write them. And of course, there's nowhere else I can go from here. I can't combine them because they're not like terms. So quiet, Rat. I can, like, the squeaky bicycle wheel is done. Yeah, don't re-gift that to anybody. Okay, so for this one, we're gonna do it 3 times, but I'm gonna tell you that I'm gonna take a minute and I'm going to rewrite my original equation. So it's still my y. I haven't derived anything yet, like I'm not doing the derivative. I'm just rewriting it because I want to change that to an exponent. So I know I've got a +2 here. I know it's going to be an x. I know it's going to have an exponent of 1/2, but I'm on the denominator, so it's got to be an exponent of -1/2. Super easy to forget those things. Like, this is all stuff we know from the math that we've done, but super easy to forget those little things as you go through. So now really what you're going to do is you're going to derive each one of them. You're just going to treat them as 3 separate things, and you're just going to apply those power Power rules. Did you get it, Rahat?
Yep,
You got everything?
yep.
You got the -3/2? Did you use fractions or decimals?
Fractions.
Nice. Did I need to rate the 1 there? Did I need to
No.
rate that? Am I wrong if I did?
No.
No, it's fine. All right, and that's it. Like, once you go to the derivative rules, things get a lot faster and you don't have to prove them. But you still need to be able to do it to show me you understand the D2, the definition of derivative. So you're going to need to do the long part for the quiz and the test for the D2 outcomes. Even though you can answer them much faster using D3, I need to know that you can do the long way.